Uh, Vanessa, please, can record it, the meeting.
Yep, you're good to go.
Great. Um, well, welcome everyone to another Tech Talk. I am Wilbur, and today I will talk about service monitoring with anomaly detection in Prometheus using artificial intelligence. And to explain this, I will using a Facebook library in Python named Profit. And let's start. Here we have the golden circle. It's a framework for understanding the core elements of an idea. And we have why part, the reason for using anomaly detection in AEOps is to identify unusual or unexpected behavior in IT systems, which can indicate potential problems or issues. About the other circle in how, um, anomaly detection in AOps is typically achieved by using machine learning algorithms to analyze data from multiple sources, such as network traffic, system logs, and user behavior. These algorithms can identify patterns and trends in the data and can flag any strange patterns that might indicate a problem. And the last circle is about what. Um, the end result of using anomaly detection in AOps is improved visibility and insight into the behavior of IT systems, which can help to prevent or mitigate potential issues before they cause significant problems. Um, Okay, right, fine, guys. I talk about the three necessary things about this presentation, but what exactly anomaly detection could be? Now I will explain this part in more details. And in data analysis, anomaly detection is generally understood to be the identification of rare items, events, or observations which diverge significantly from the majority of the data and do not conform to a well-defined notion of normal behavior. For example, like we can see in these photos about graphics and fish detail. When we have normal lines or clusters, and out these clusters or these lines is possible to see some points or different points. All right. Okay. And what is AOps? Uh, AOps, or artificial intelligence for IT operations, is a term used to describe the use of artificial intelligence and machine learning techniques to improve the efficiency of IT operations. Um, this can include tasks such as monitoring and managing network and system performance, identifying and predicting potential issues, and automating routine tasks and process. Um, AOps can help organizations to improve the availability, reliability, and performance of their IT systems, um, reduce the amount of time and effort required to manage and maintain them. And AOps solutions can also provide valuable insights and data that can be used to optimize and improve our IT operations over the time. Uh, Now, let's see our necessary tools to make it possible. Let me pass here. All right. Fine. One of the tool used to make this possible is Prometheus. Prometheus is an open source monitoring and alerting system for distributed systems, and it is designed designed to collect metrics from various sources and to provide a flexible query language for analyzing and visualizing the data. And Prometheus is widely used in the field of infrastructure and application monitoring, and it's known for its reliability, scalability, and simplicity. Um, well, in a few words, Prometheus is a monitoring solution for storing time series data like metrics. And here, after Prometheus, more at right side, we have the Grafana, how allow us to visualize the data stored in Prometheus. And here we have an example used to monitor the Kubernetes cluster resources and well applications too. Okay. Uh, Now let's take a look about our main tool to help us in this analysis. Remember, it's a tool, not the final data. Uh, Profit is a popular open source forecasting library developed by Facebook. It is designed to make it easy for analysts and developers to create high quality forecasts for a wide range of business and economic time series data. Um, Profit is based on decom- decomposable time series model that is flexible and can be easily customized for different types of data and forecasting scenarios. Um, it's widely used in fields such as finance, retail, and e-commerce, and is known for its accuracy and ease of use. Um, okay, all right. Uh, Inside profit universe, we have three important values to know. And guys, please focusing here. Now details could be more confusing. We have these three um, values on the screen. Uh, the following are the forecasted values used to predict it, and the first is YHHIT, uh, used to predict it time series value. The other is about upper, um, used to bound of uncertainty interval, and the lower for uncertainty interval, but in lower scenarios. Okay, the first is the main forecasted value, which is the most likely value of the time series at each point in the future. The other two are the lower and upper bounds of the prediction interval. These bounds represent the uncertainty in the forecast and can be used to access the risk associated with the final forecast. Um, okay. uh, for example, if the predicted value of a time series at a given point in the future is 10, for example, and the upper and lower bounds of the prediction interval are 8 and 12, respectively, uh, then this means that the actual value is likely to be between 8 and 12, but the most likely value is 10. I'm not sure if that's part. Sometimes it's confusing, but after will be more clarity. Oh, um, but remember, the power of the tool is designed to analyze time series that show patterns on different time scales, such as annual, monthly, and help us to predict anomalies. Um, okay. All right. Yeah. Now we know about Prometheus and Prophet. The great thing to stop and think is how Prometheus and Prophet could work together. Um, the short answer is depends, like all in IT universe. um, they could potentially be used together in a number of ways, depending on the specific requirements and goals of the organization. Um, Prometheus could be used to set up alerts and notifications based on certain thresholds or conditions being met in the data. For example, if the forecast generated by Profit indicates that a particular metric is likely to exceed a certain threshold in the near future, Prometheus could be configured to send an alert to the appropriate team or individual person so that they can take appropriate action. Or you include this logical inside operator in Kubernetes, for example. Or uh, other option is Prometheus could be used to collect and store metrics from various sources such as application, performance data, system logs, and network traffic. Uh, this data could then be fed into Profit for analysis and forecasting in order to identify trends, patterns, and anomalies that may indicate potential issues or opportunities.
Wilbur, quick question here. So for profit, Prometheus can be a data source, and but you can have multiple data source feeding into profit, right?
Right, totally right. But all data need to be analyzed individually.
Gotcha.
All right. Um, and for our case today, we are using something like this last mentioned one, and overall Prometheus and Profit could be used together in a variety of ways to improve the monitoring, analysis, and forecasting of IT systems and applications. Uh, okay, and well, now is the code time. To be more easy, I was using Python in this example, and I will show some um, steps inside the code and what is the output from these steps. Um, and just to remember, guys, at a high level, the outliers are detected based on the prediction interval of the time series, and the implementation includes the following steps. Um, build the first is building a time series forecasting model. After, make predictions on historical data using the time series forecasting model. And the final is compare the actual values with the prediction intervals. Outliers are defined as the data points with actual values outside of the prediction intervals. Um, all right, 1 second. Let me. Okay, okay. Well, here we have this data in left side. Uh, the data is provided from an open Grafana dashboard. This data comes from the systems of Wikipedia, an American no-profit company. I will leave the link to this dashboard at the end of the slide. Um, and in order to avoid waste too much time, I selected a simple data of login attempts with wrong password. For example, it could be a hacker attack. Okay, I exported the data from this dashboard during 1 year, and after here in the code, we have the import of data and all the initial manipulation of that data. This part we don't using yet profit. We just manipulate the data and clean some details about data. All right. Any question about that part? Okay. Okay. Next, after we run the last maintained code, we can see the formation from the same graphic as in the Grafana dashboard to confirm if your data is okay to look. For example, here we have this type of graphic, and after our graphic. And okay, okay. Here we will build a time series model using Profit in Python. We need to change the names from time and wrong password to DS and Y. And after we add seasonality, and some interval width, which means that the indecision interval is 99%. And the last part is about model. Or here we training our dataset, and in the after we make predictions, finally we are using a Prophet library, and in forecast variable we make a prediction using the imported data, and we visualize this prediction. Let me show here. Okay, here after we built a time series model using the Prophet in Python, uh, it's possible to see the forecast plot shows that predictions are in general aligned with the actual values here in blue line and black dot points. All right. Just to remember, it's a prediction, okay? Not uh, the original value, but it's really similar to the original value. Okay, and now it's time to identify anomalies. Here we will identify the time series anomalies by checking if the actual value is outside of the uncertain interval, if the actual value is smaller than the lower bound or larger than the upper bound of the uncertain interval. The anomaly indicator is set to 1, otherwise it's set to 0. Um, after using value counts, uh, we can see that there are 9 outliers out of 355 data points. Here more below, the number of anomalies in the dataset is 9. Uh, and after print out the anomalies, we can see that all the outliers are lower than the lower bound of a certain interval. I will show in the next slide. But here below, it's possible to see in all detected anomalies and what is the data of this anomaly and what is the value. And well, that's so great because now with this information, it's possible to plot this in a graphic, um, or apply some logical inside this information. Okay, here we have the visualization about anomalies. All the dots are actual values and the black line represents the predicted values. The orange dots are the outliers. Finally, it's our anomalies. And well, it's possible to see some points, some teeny points here, uh, happening in my and after others months. And well, at the final point, suppose in this scenario, the tentative of logging with a wrong password is an hacker attack, and we want to predict this. Can use the Prophet library to forecast the probability of future password hacking attacks. And well, that's great, not just for these hacker attack scenarios, but with many others type of scenarios. Uh, Anybody have a question about this graphic or about these details?
So this chart is projecting the future. It's not the past, it's the future, right?
Right. And it's possible to extend this to, for example, for 1 year, in a more 1 year in future too.
Okay, thank
So,
you.
no problem. Uh, okay. And well, just to conclude the main idea behind all details, uh, the use case for this framework is to assist teams in real-time alerting of their system application metrics, and the time series forecasting performed by the models can be used by developers to update their systems, to tackle the anomalies in the future, and work, for example, with Kubernetes operators to help predict and work in many anomaly scenarios to avoid future problems. And well, it's a great tool we have actually. And well, some situations we need to stop and analyze all data to make great predictions, but in a few words, it's so great for future IT operations. And well, guys, that's all from my part, and now I open to questions. If anybody have questions, we have 10 minutes.